Drones have revolutionized our world. They're delivering medicines, mapping coral reefs, and will even transport people. The same drones can be used to deliver weapons, take sensitive footage, and transport illegal immigrants. Drones can target nuclear power plants, airports, Capitol buildings, prisons, iconic buildings, political convoys, crowded areas, oil refineries, and oil rigs. That's why we developed Indrajaal. Indrajaal is an autonomous drone security system that can defend against all drone classifications. Unlike traditional counter-drone systems, Indrajaal is a 360-degree drone security system designed to protect wide areas using networked architecture, multispectral detection, central autonomous AI, and parallel weapons engagement. Indrajaal combines 12 proprietary technologies to achieve this for the first time in the world. These include Green OS, patented autonomous resource planning engine; Defense OS, unified command and control engine; HiveMind, AI computer that can plan and execute missions; Zombie Drone, level 5 autonomous drones that can kill threats; Skycop Drone, level 5 autonomous drone that can watch threats; Brig Device, Edge AI smart data and control device; Repulsor, uses a tractor beam to jam and control drones; Spider Mesh, high-speed wireless mesh network covering up to 4,000 square kilometers; Green Eye, uses machine vision to identify threats; Hypersensing, a potent mix of sensing technologies; Weapon Fusion, make existing weapons autonomous by integrating them; Global Grid, unified real-time command and control interface. Indrajaal's command and control center provides real-time situational awareness with minimal human intervention. This means the system can swiftly and intelligently respond to drone threats. Indrajaal's 5-step drone defense process starts with detecting all the drones in an area. Integrations with local aviation and military systems enable Indrajaal to identify friend from foe and classify the drone. It can even track and intercept multiple drones simultaneously. Indrajaal tracks the speed, angle, and trajectory of all threats in a given area with predictive weapon engagements. If the drone is perceived to be a threat, Indrajaal's advanced countermeasures are activated. These include both soft and hard kill options, such as jamming the drone's control signal, disrupting its navigation systems, or even destroying the drone itself. Indrajaal's autonomy engine ensures that any drone threats that might have escaped a weapons envelope will be retargeted, followed, and eliminated. Indrajaal was originally conceived and partly deployed to protect the critically important Independence Day Parade in New Delhi, India's capital, in 2021. Powered by a proprietary AI platform, Indrajaal draws on Green Robotics' 15 years of R&D in autonomous systems, combined with a team having 3 decades of expertise in radar and airspace management. Indrajaal is perfectly suited for protecting critical infrastructure like nuclear power plants, airports, Capitol buildings, prisons, oil rigs, oil refineries, iconic buildings, large gatherings, convoys, as well as larger areas like the border. Indrajaal is always evolving, so you can be confident that your airspace is fully protected from the changing threat of drones. Protect your airspace with Indrajaal, the most advanced counter-drone system in the world.
It is the design philosophy and why we built what we call the most advanced counter-drone system in the world. I'll run through a few slides and explain, sir, and then we will move on to the next. Indrajaal was fundamentally designed to fix threats posed by drone, and we know that this proliferation of drones is increasing by the day, and drones of all classes can be built literally on the rooftop next door, and they are a threat for a variety of our installations. And the major threat also is coming from the ability to swarm and also maneuver independently, autonomously, without any control. So considering that, we studied the entire threat pattern, and we have looked at the design philosophies and principles to make this literally future proof. All existing capabilities have been subsumed, and everything that's going into the future, we have made provisions like a true network-centric operations platform. The major consideration we believe is that the future is not about drones being in the sky, but 99% of the drones being friendly. It's not a simple 0-1 binary where we see a drone, engage it and neutralize it. We may have to definitely verify, because lots of friendly operations are being enabled by drones. They're a fantastic platform, and they are in use by various governmental and military and paramilitary institutions for legitimate purposes. But verification instantaneously has become a necessity going forward. Otherwise, we will interfere with each other's operations. So we believe that the drones are all not of the DJI, not of the small micro drone category that we commonly consider as a threat, but they are going all the way up to medium altitude and high altitude. 3 wars in recent past, Armenia, Azerbaijan in the Balkan region, the current Ukraine-Russia conflict, as well as the attacks on the oil infrastructure in Saudi are bearing out that they are using drones which were discarded in the past. That means we believe that drones need electronics, drones need to be equipped with modern missile systems, and they need to be fired from the air. But they say using simple plastic drones, simple wooden drones, and putting 30 kg of explosive and pushing it into the enemy territory. So this is the kind of threat which is also of significance, in addition to small drones which are coming in for communication disruption, snooping, and so on and so forth. So the full spectrum of the drones has been considered, the entire threat spectrum has been considered, and they have been unified, the response to which has been unified in a singular integrated command and control platform. We have made significant provisions for verification of identification, so that we do not have blue on blue. We do not want any engagement of owned drones. So we have integrations with the existing airspace management system of the country, as well as the verification with the Civil Aviation Airport Authority initiative called the Digital Sky. The system is capable of managing the flight paths, so every single public source information on drones or any flights that are legit will also be subsumed into the system to ensure that instant verification happens at the system level before reaching out to the airspace management. And based on the verification, an agency can be authorized to engage within the permitted zone of his jurisdiction. For example, an installation could have a 500-meter buffer zone within which you can initiate actions, and you can engage them when he enters your jurisdiction. So the provisions in the system facilitate detection, verification before the engagement actions are suggested by to the operator in an autonomous manner. We've also done a significant modification to the way the user interface operates with the system. We have gone into a world-leading touch display system where lots of operation can be done simultaneously. We'll show you a glimpse of that, and you will see the entire operation happening on a single touch on the display in my subsequent live demonstrations as we go forward. One of the other imperatives is that standalone systems like the point defense systems, that means you would like to defend a particular VAVP or a base, you would deploy all your assets in one central location. This will lead to limitations of 2 to 3 kilometers, 5 kilometers of protection. But when we talk of linear infrastructure like the border area, a large area like the national capital region, you may require distributed detection and distributed engagement to ensure that the entire area is contiguously managed. So we looked at the problem statement that point defense is not the future. We moved away into a meshed area defense process, and we have built Indrajaal to ensure that we can spread the meshed connectivity as far as possible. This is a representative. We do not want to represent Indian airspace here, but a typical mesh will also look at a critical part, which is the real-time communications in the last mile. Every single weapon system, every single radar is not going to be deployed within the reach of fiber optic networks. So we have looked at the wireless mesh connected requirement of the system. It's also a part of one of the technologies of Indrajaal that you just saw in the first 12. This mesh network is scalable. It can be deployed. We do not want to say that it is absolutely scalable. It can be deployed from 2 by 2 kilometers to 80 by 50 kilometers. A single scalable meshed architecture is running at the back end with one of the proprietary technologies that we are looking at. Physical enablement is using the mesh radio network. Interfaces are happening through the Defense OS platform, and the entire output is on a single touch interface. So it's a seamless transition to move to say I can protect a tactical battle area or a large oil installation or the national capital region from a single location. The principle we did not want to violate is unity of control. If we deploy 20 systems to deploy a front, then there will be conflicts of command and control, which the design has catered to ensure conflicts are minimized. So what we did is we fused multiple detection capabilities. We believe that no single sensor is capable of actually spanning the entire spectrum. What comes on radar may be limited to a particular range. What comes on active emission from the target will be detected on a different layer. If he is coming silent, it will be detected on a different layer. If it is coming by night, it will be detected on a different layer of our detection mechanism. There is also a thermal, there is also an acoustic, we have catered for all kinds of, the entire spectrum band of detection is being put in. We have taken that and we fused it into a multi-sensor fusion application to ensure that the enemy has no escape. A silent drone is detected as well as drone which is emitting. Somebody coming on GPS denied environment is also detected. Somebody coming in a low visibility signature is also detected. While we discuss countermeasures, while we just spoke about the sensors and the ability to actually detect across the spectra, across the entire spectrum, what we need to look at is that there are multiple countermeasures which are in use. One of the most popular countermeasure is the jammer, that is the repulsor in RF cases. We studied this countermeasure. We have integrated this countermeasure. It is one of the options. What we want to leave the audience thinking is that there is no one single countermeasure, one single detection mechanism, and Indrajaal caters for the length and breadth of this. There is another very popular weapon system, laser. We have had the good fortune of integrating during our Independence Day deployment, which was just indicated earlier. Laser weapons are very potent against a certain class of threat. We have not ignored that. We have also included that in the weapon mix. But the underlying philosophy we would like to leave the system with is that it is, while we integrate individual layers, it is the application, which is the AI-driven application, which decides the best course of action using the entire weapon mix at our disposal. So every force is free to choose the weapons of his choice and deploy it the way they want to employ. For example, in an urban environment, we may not be able to shoot lead against a drone, but you may be able to use lasers. But again, you may be able to use laser, you may be able to use jammers. But again, the restriction as to ensuring that the other friendly flying is not interfered with is an important activity. So we have done integrations on lasers, anti-drone missile systems, manpads. The entire stack of integrations is inside the Indrajaal system at this point of time, and we are ready for more. If there is anything coming up in the future, we are looking at adding that to the layer. The end result is that we must have minimum collateral damage to other operations. Every other operation must be allowed with its own degree of freedom. Maximum degree of freedom must be available to friendly forces using this while they are using this particular system. Swarms are another major threat that we need to look at, and once the swarm attack is in progress, we may have to use artificial intelligence to encounter the swarm, because swarms come, they are partially silent, partially they are emitting, and they are in large in number. Any serial engagement mechanism that we look at may not satisfy the purpose. Indrajaal caters for an ability to optimize the resource employment against all the elements of the swarm. We've built something very interesting which is called the countermeasure for swarm drones. The swarm drones will know where your ground defenses are. They will operate outside the range, so you may have to reach out to that and observe it while it is in operation. So a standoff jammer will not come into the weapon capability of your own system. It will stay outside the range. So then it is always necessary to reach out to extend your area of detection, reach out and extend your area of engagement. So we built something very unique. You will see a live demonstration of that. Is a drone. The drone that can go out, it can function in two flavors. It will also detect and report as to what it is detecting. It can also quickly convert into a zombie drone. A zombie drone is something which will go in a kamikaze mode and end the target. Once it is decided it's not friendly, it will go into that particular drone. So we've extended the counter drone philosophy in two flavors, Skycop and Zombie, to ensure that whenever we have a swarm attack, we are in a position to go and take one-on-one all the important queens in the swarm. Indrajaal is actually, we have full stack integration across sensors and weapon systems, all existing sensors and weapon systems that are on offer for counter drones and more, even for conventional air defenses, are all subsumed into our stack. We are technically sensor and weapon agnostic. The requirement is to define the problem statement, and Indrajaal as a platform is ready to morph into a environment for deploying a particular framework. So all kinds of radars and all kinds of sensors and all kinds of weapon systems at this point have been integrated into the platform. Coming to the multidimensional problem statement, sir, this is a full stack of the kind of drones that we are seeing at this point of time. While we are concentrating at the bottom, mostly at the micro level, most of the conversation is actually centering around the micro drone, because it's the most common. It can be built on the next door rooftop, it can be flown up to the next 20 minutes, it can fly up to 500 meters. But the significance comes when we look at medium altitude long endurance drones, the kind that are being used, that are supplied out of Turkey and Iran and China, that they being supplied to current wars, current engagements. It's a medium altitude long endurance drone which can stay up at 15,000 feet for 10 to 12 hours and carry significant munition, which is a threat. This is in detection of this particular layer, as well as detection of something called the HAIL, that is high altitude long endurance, which is far more difficult to detect because of the altitude at which it operates and the deficit of significant sensor cover at that particular altitude. This also needs to, when we look at the full stack, this is the full threat. Let's not look at just the micro drone, we are looking at the entire stack, and we have worked out a philosophy of detection using a combination of sensors. Some are very, very specific to that particular type of threat. The identification itself, the tracking and targeting. So when you have multiple sensors sending in the data, we need to do something known as hypersensing, which is one of the technologies that we employ. And also for countermeasures, we have a mix of potent weapon fusion, which with the weapon fusion algorithm ensures that the right weapon will be used for engaging this. For military areas, you may need full spectrum employment. For other areas like urban areas, there may be some restrictions on weapon employment. Certain classes of threat are not under your jurisdiction, but they fall under the military. So there is a separate set for the urban areas. A solution of Indrajaal can work in the urban areas. A solution of the same can work for civil airports, considering the way they need to operate. There is an electronic emission restriction. They already are using a part of this frequency set. You may not want to interfere with your own set of sensors and countermeasures. There is a different flavor of Indrajaal which can work in a civil airport. We have the framework in place. Also something for point defenses like prisons, government buildings, and important VOVP installations. So Indrajaal comes in a variety of options. It is scalable. It is a network-centric system. It is completely indigenous, and it is future ready in terms of what we can take it from this point of time. Yes.